Well, let us discuss now cells in series and parallel. Let us think about a device. This is one device that requires DC voltage between 4 to 6 volt. Then how we can supply this device? Each cell is having cell voltage is equal to 1.5 volt. This is the symbol of the cell. So EMF of the cell is E, that is equal to 1.5 volts. Now how we can supply this device 4 volt or 6 volt? That in that case we have to connect the cells in series. You can see that there are 3 cells that are connected in series, and each is having 1.5 volts. Okay, this 3 cells are supplying this device or any appliance. Okay, now there are 3 cells connected in series. These are the cells forming the battery, and the total voltage of the battery, that is E dash, that is 3 into 1.5, so you get 4.5 volts. Okay, across the terminals of the battery, considering the internal resistance is 0. If there is internal resistance, then we have to consider this. So this arrangement can be replaced by this is the device, and this is the battery EMF or voltage across the terminals of the battery, that is 4.5 volt. And if we require more voltage, then connect more batteries in series. Connecting one more battery, it will be 4 into 1.5, that gives us 6 volts. Okay, so this in this way the voltage across the device can be increased according to the requirement. And if there is the internal resistance, this circuit can be replaced by this is the internal resistance, and this is the combined EMF, that is E dash is equal to 4.5 volt, and this is the internal resistance of this battery. Okay, this R dash is equal to how much? If there are 3 batteries, that is equal to 3 into R. Okay, suppose R is equal to 0.1 ohm, so R dash will be 3 into 0.1 ohm, that is equal to 0.3 ohm. R dash equal to 0.3 ohm. So if there are n cells in series, then R dash is equal to NR. Then in that case E dash is equal to NE, and R dash is equal to NR. This is the cells in series, and the cells also can be connected in parallel. Let us do it. And this is one device that requires some voltage, and that current what it requires, that current may not be supplied by one battery. That's why batteries are connected in parallel. Suppose this device requires 2 ampere current, and each of these batteries can provide only 1 ampere. Then so in that case we can connect 2 or 3 batteries in parallel, so that that current will be shared by these batteries or cells in parallel. So these you can consider as cells or batteries. Let us think that these are the cells. So the EMF of each cell is E, and the cell is having an internal resistance of R. For this all these 3 cells, it is the same. Their EMF is E and the internal resistance is R, and each is able to inject current IC into this main circuit or into this main branch. Okay, so if there are 3, then you can say that 3 times of IC is equal to I. If there are such n numbers of cells in parallel, okay, there are more cells like this, the n such cells in parallel. So what we can say, IC into N, that means N into IC, that is equal to I, terminal voltage, that is the voltage across the device. What will be this voltage? Let this voltage is V. V is equal to E minus IC. IC is the current, this same current IC that is flowing in this branch, all these branches. Okay, so E minus IC into R, or otherwise we can write it as V is equal to E minus IC is how much? That is equal to I over N. Okay, multiplied with R. So you can write it as E minus R over N multiplied with I. So V voltage across this terminal of this battery, that is equal to E minus R divided by N I. So from this formula we can say that this arrangement can be replaced by device. This is the same device, and this is the resistance of the equivalent battery. This is the battery that replaces this, all these cells in parallel. So this battery voltage is E, and this resistance, internal resistance, that is equal to R divided by N. R by N is the internal resistance of this equivalent battery that we obtain by replacing this. Okay, so this is equivalent to this circuit. You can see that the EMF remains the same. Okay, so the internal resistance has become R divided by N. You can see that the same current I will flow. So E minus I into R by N, that is the voltage across this battery terminals, or the voltage across the device. The same voltage is, this voltage appears across the device. This arrangement of cell in parallel is equivalent to this battery, that is where the EMF remains the same, but the internal resistance reduced to R by N. R is the internal resistance of each of these cells, and there are N such cells in parallel. So this is the equivalent of batteries in, or cells in parallel. If you will connect one cell across this device, then one cell will have to carry the total current. But here in this case, all these cells are carrying the current equally, I divided by N current. That's all for now, and we'll discuss more later.